Hey everyone, we're doing real life world problems regarding the triangle inequality theorem. One's regarding, we do them the same way, but two different scenarios. So we'll start with this one. Two airplanes leave the airport heading in different directions. Okay, so after 2 hours, one airplane, so here's the two airplanes. Let's go this way and that way. So has traveled 710 miles. And let's say the other one has traveled 640 miles. And so they want the range, and this is just a makeshift drawing, of how far the planes could be apart. I could have drawn this line anyway, so this is just like not drawn to scale or anything. So basically, we're going to use our triangle inequality theorem. And first, we have an x here. That's what we're looking for. So we have three sides. So I can say 710. I'll leave the miles out for now. Plus 640 has to be greater than x. So that's going to be, I believe, 1350. And that's 1350 has to be greater than x, or we can write that x is less than 1350. Now what I want to do is set up the other two sides, and I'm not going to use all three because one won't work. So I'm going to set it up as x plus 640 has to be greater than 710. And you subtract 640 from both sides, and you'll get x has to be greater than 70. If you switch these two numbers around, you'd get a negative x, and we don't want that. So you don't have to do that. So basically, we have to describe the range. So the range is going to be it's like the distance is going to be in between 70 miles and 1350 miles. And this should be miles here. Miles. And this one's miles too. All right, and the second problem is very similar. All right, so basically we can set this up like, think of the 60, let's read it. A pitcher throws a baseball 60 feet from the pitcher's mound to home plate. A batter pops the ball up and it comes down just 24 feet from home plate. What can you determine about how far the ball lands from the pitcher's mound? So let's say we can set up as a triangle and say like this is 60 feet. And then say this is 24, where he pops it up. And then we need to know how far this length is. So we'll just call this the distance. So basically, we can set it up as 60. We're using our triangle inequality theorem. Plus 24 has to be greater than the distance. So 84 has to be greater than d. Or we can say d is less than 84 feet. And then we do the same thing. We're going to write d plus 24 has to be greater than 60. Subtract 24 from both sides of the inequality, and you get d has to be greater than 36 feet. So d has to be in between 36 feet and 84 feet. Now, it says that can be used to describe all but the shortest and longest distances. It could equal it, but that's not what the question is asking. So we're going to take away these inequalities. It's not accounting for the 36 and the 84 feet. And that's it. Thank you. Have a nice day. Bye bye.